Hello. I hope you are doing fine. Okay, welcome back here in our class of design of retaining wall according to Eurocode 7 and following the France standard. Okay, so this is application of Eurocode 7 in France. Application how to design retaining walls. Okay, so this one is the second video in this program, and I will try to go really slowly and make short video so that you can follow and understand easily. Okay, so as usual, we will do this video in French also. So if you are interested in French version, you can get the link in the comment. Anyway, so previously we did also this chapter 1. We started this with chapter 1, and today also we will work on the same chapter, because as I told you, we will try to make very short videos. Okay, so chapter 1 general. So previously we talked about this first point. About this point talked about what type of retaining structure are concerned in this class, in this design. Okay, and this video is about the failure mechanics of the retaining walls. This part is very important because we need to know the failure mechanism of the retaining walls so that we can bring solution to these failure mechanisms. Technically, designing the retaining walls is just bringing solutions to avoid these failure mechanisms. That's why the failure mechanisms are very important. So I hope you will understand and you will take this video very seriously, because if you miss the failure mechanism, you will not be able to understand or to design anything. Okay, so this failure mechanism, we will try to be very short in this video. Okay, failure mechanism or retaining wall. What are the different failure mechanisms of retaining walls? So we have several mechanisms, and I've tried to categorize them, okay, in few categories. So maybe this category will include everything. If you know any other failure mechanism that I didn't include in this video, maybe you will find the category where you can put it. So the first category here, first category of mechanism is the insufficiency of resistance of the ground. The ground in contact with the wall, if that ground is not strong enough, it may cause failure of your structure, of your retaining wall. Okay. In this category, I will give you two cases, and each case will come with example. Okay. The first case, when we have abutment defection at the foot, means at the bottom of the excavation, for example. Okay, that happen when the plug is not enough. Okay, here is one example. In the case of freestanding retaining wall, means this type of retaining wall, we don't bring any support. it's standing alone. Okay, so the same type is shown here with color and slip surface, slip line. Okay, slip surfaces. So in this situation, what we can get is rotation, tilting, if rotation center being around this point. Okay, so remember this category, I mean this case, this situation, abutment deflection is because this part in the soil, in the ground is short. Not the length in the ground is not enough. Okay. In that case, we may have this kind of situation. This is first example. Second example is when we decide to bring support at the upper part of the structure. Okay. Remember this case, the wall was self-standing, no support at all. Here we decide to bring support the upper part of the wall. In this case, we may have rotation. It's same case here, just color. Okay, same thing. We may have rotation around a support in the upper part. So the action will be here. Okay. Third part of this type, same here, is when we decide to bring support at the bottom of the lower part of the retaining wall. Okay, in that case, we have possibility of rotation, tilting around this point. Okay, well, this is the first case. Second case, same category. Second case is lack of vertical balance. In this case concern the retaining wall that are mechanically loaded at the head, means retaining wall that are used as foundation, okay, or those who are anchored by very inclined tight rod. So this case is shown here, the situation is shown here. This is just about failure of bearing capacity, okay? We have here, load here, the head. So the wall is used as foundation, and the problem is happening here, the failure of the ground. So both type are about the ground. The resistance of the ground is not enough. First case is the abutment. Okay, the length in the ground is not enough. Second case is the bearing capacity itself. So this is the second category of the failure mechanism of retaining walls. Let's go to the third category. The third category is rupture of the ground around the support. So sometimes, as you saw in the two previous slides, we use support to support retaining wall by using anchor or support. Okay, so for this category, the ground around those support, the rupture is happening around the support. First case is instability of reaction block. For example, if you take this one, do you remember this figure? We have support here. Let's imagine that we have a reaction here to around the support. the reaction here, the failure may happen in the reaction if there were, for example, soil here to support this, as a reaction of the support. Okay. Another case is local instability or global instability in the ground around the support itself. This is an example. We have anchor here, and we have local instability here, like low. This is going down, and it causes three blocks failure. This block, and this block. We have also global failure. But remember that all these failures are about failure around the support, ground around support. Okay, so in this case, this whole area may be unstable. So instability of this zone. For the previous case, when I said that the abutment is not enough, the length in the ground is not enough, I think you know the solution. It's very easy. It just you have just to have enough length in the ground. Okay, the part of the pile or your wall need to be deeper in the ground. How about this case? What is the problem with this case? In what situation this kind of failure may happen? This happens mainly when this support or anchor are very short near the wall. So we need to drag the line continuously far away from the wall itself. Another category of failure is lack of resistance. This time, it's not about ground or soil around the pipe and the wall or support, because the previous category, all of them were about the resistance, the capacity of the ground itself. But this time, it will be about the resistance of the structure itself, the capacity of the structure itself. Okay, so when you see screen here, it means wall. Actually, it translated from French. That why. So structure, the resistance, the capacity of the structure itself, of the wall. Here we have this figure showing example. First case, we have a free self-standing wall. In this case, we may have here rupture of the structure itself. So the wall may break around here. In this case, B is when we decide to bring support at the upper part of the wall. In this case, in this situation, we may have two breaking points here and here. The structure itself will break. Or the third case, we may bring many supports. In that case, we may have breaking here. The wall may break here. This is about the structure. Second case is about the support or the anchor. Okay, the translation is not good here. Okay, but I think you understand what I mean. This case, this example will help you to understand more. This is directly translated from French. That's why the translation is not good. But anyway, this figure will help you to understand what I mean. So here, the first case, case A, we have the failure of the anchor. This anchor is breaking around here. Okay. And this B case is the support will break. And the last one is when the anchor itself is becoming loose. So around here, the ground around the anchor here is becoming loose. So no resistance anymore. Okay. So this is another category of that may lead to the failure of your retaining wall. Let's move to the following categories. I think there are two more categories left. Another category is instability of in the bottom, the excavation. So because the retaining walls are mainly used in case of excavation. So how this retaining wall may fail due to the instability in the bottom of the excavation. This is another category of failure mechanism. Okay, so we have the mechanical origin one, failure of mechanical origin, solid forks. Okay, maybe you know if you remember your soil mechanic class. We may have also hydraulic origin one, means hydraulic failure. This is an example. We have here the retaining wall and the excavation is done here. Number one here is the level of the excavation. This number one at the right side is the level of water. Water table is here. Okay, so all this is water, number two. Number three is sun. So as you know, in the soil mechanics class, water will come here from the top, because here the head is too high. So water will flow from here to here, like this. So if the height in the excavation is not high enough, this is not high enough, so the water may push, lift actually the most, because water is pushing upward, and if you're not careful, this water may lift in the excavation, this part, and it will result with instability of the retaining wall, something like that. Okay, the last category is general instability. This general instability means everything is collapsing. The ground and the wall. The ground will take the wall. This is example. This figure is showing us two cases. First case is non-circular failure surface. It goes like this. As you can see, the wall is not penetrating in this part of the soil. So the failure is going like this horizontally here and doing like this. Second case is when we have circular failure surface. Okay, so as you can see, everything is going away like this. So even the anchor didn't help it. That's why in the design of the anchor, you will see in the program of Eurocode 7, not this one. This one is Eurocode 7 applied in France. So you will see that in design of anchor, we need to do like the anchor length need to be higher than this. It need to go above this line. Okay, so means you need to know to estimate the slip surface first before you design the length of your anchor. So I think that's all for this video. So as I said, this video is really important because it is about mechanism failure, and knowing mechanism failure will help you to know or to seek solutions on how to prevent this failure. Okay, so solution to this failure mechanism are just what we are calling design. Technically, design is just solution to this failure mechanism. So that's why knowing this failure mechanism is very important. Okay, so I hope you have learned something, and let's see you in another video. Thank you very much for your time.